Now we are going to look at sections 2.2 and 2.3 for exam 2. For the first question, how many subsets of the set S equals the letters P, R, I, and C, E are there? Now for this question, we can list all the subsets, but that's going to take a long time. Instead, I'm going to use the formula to tell us the number of subsets. The number of subsets is equal to the formula 2 raised to the n. This is going to tell me the number of subsets. And n is how many elements we have in our set. We have 1, 2, 3, 4, 5, 6. So in this case, n is equal to 6. Using the formula, we have 2 raised to the 6th, and this is equal to 64. There are 64 subsets. It would take me a very long time to find all of the subsets, but they are only asking how many, so we know the answer is 64 subsets. Question number 2. We're going to list all of the subsets of S, being the letters K, I, N, and G. Now this one they actually want to list, but let's use the formula for the number of subsets, and that's equal to 2 to the n. In this case, we have n is equal to 4. So 2 to the 4th is going to give me the number of subsets, and that's 16. So I know if I list all of the subsets, I should have a total of 16 subsets. Now let's list these subsets. I always start with the empty set. That's always a subset of every single set. The empty set is always the subset of every set. So start with that. And then I will start with the singles. I can have a K by itself, an I by itself, N, and G by themselves. So we have the empty set, and then the sets with only one element in them, and then we'll do the sets with 2 elements in them. I have K and I can do a K and an N. I could do K and G. So these are the sets with 2 elements starting with the K. But remember, if you switch these around and write KG, that's the same subset, so don't make any duplicates. KG is the same as GK. And I can also write IN and IG, and we can also put NG. So we have the sets with 2 elements, KI, KN, KG, IN, IG, and NG. Okay. So you're just going to have to use trial and error and just make sure you don't repeat any of these sets with 2 elements in it. And again, if I switch the letters, it will be the same subset. So KI and IK are the same set. So we have the doubles. Now we'll look at the sets with 3 elements in it. KIN is one we can make. We can also do KIG. KNG. ING. And so that's it for the sets with 3 elements in it. We have KIN, KIG, KNG, and ING. Double check to make sure that I did not miss any of the 3 element sets. And now we can count to see how many we have. There should be 16 total. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're missing one more set, and that's the set with all 4 elements in it. That's the set K-I-N-G. The whole set is a subset of itself. So that's all 16 subsets. We know we did it right because there should be 16 subsets. So start with the empty set, then do all of the sets with only 1 element in it. Then do all of the sets with 2 elements in it, all of the sets of 3 elements, and then finally the last one has only 4 elements in it. Given the universal set U is PRSTUVWX, and the set A is equal to PQRS, B equals RTW, and C equals TVW, find each of the following. Let's find B union C. To be in B union C, you have to be in B, in C, or both in B or C. So I'm just going to make a list of all of the elements from B. Here is B union C. That's basically, I'm going to list everything in B and everything in C, making sure there's no repeat. I don't need to list the T, I already have it. I don't need to list the W, I already have it, but we need to add a V. So this is the set B union C. We just have to make a list of everything from B and everything from C. Don't do any repeats. Question number 4. I'm looking for A complement intersect B. A complement. A complement is going to be everything that is not in A but in the universe. We have A is PQRS. So everything that is not A would be TUVWX. So that's A complement. A complement is equal to TUVWX. And I'm going to take that and intersect that with B. B is RTW. Now, the intersection is what is in both. So we're looking for any overlaps. What's in both? They both have a W. And they both have a T. So the intersection is the overlaps or what's in both. So we have a T and a W that's in both. Question number 5, I want to find C intersect B union A. C is the set T, V, W. Intersect that with B union A. R, T, W is the set B. I'm going to union that with set A, which is P, Q, R, S. And since there's a set of parentheses, we have to do this first. So RTW union with PQRS is just going to be what's in one or the other or both. So I'm going to make a list. This is RTW. We don't want to repeat ourselves. So RTW, P, Q. I already have an R, so I don't need to list it. And an S. Now the intersection is going to be the overlaps between the two, and they share a T, they share a W, and that's it. So our intersection is TW. For question number 6, this N here just tells us we're looking for the cardinality or the number of elements in C complement. So the number of elements in C complement. Well, we'll have to find what C complement is first. C complement is everything in the universe that is not C. So let's look at our universe and look for TVW. TVW. So everything that is in the universe but not in C are these letters. So C complement is P, Q, R, S, U, and X. So this is the set that consists of C complement, P, Q, R, S, U, X. Remember, C complement is everything that is not in C, so we'll take out T, V, W from our universe. So we have P, Q, R, S, U, and X. Now N is the cardinality of this, so we're just going to tell us how many elements there are. We have a total of 6 elements, so the cardinality is just 6. The number of elements is 6. In these examples, we want to classify the following as true or false. Think about 7, 8, 9 for a moment and try these on your own. I said pause the video, try it on your own. Don't wait for me to do it. Now in these examples, if you think it's false, try to find one that shows it's false. For example, consider the set that consists of 1, 2, and the set B here that consists of 3 and 4. Here we know that A is not a subset of B, and B is not a subset of A, because none of these share anything in common. Either A is a subset of B or B is a subset of A is false. I found one that was not a subset of each other. For question 8, if A and B are set such that A union B is equal to the empty set, then A is equal to the empty set or B is equal to the empty set. We know the union between two sets A and set B is everything that's in A, everything that's in B, and everything in the overlap. So if they have anything in common, we would put it here, or if it's in set A or in set B, we would put it here. But in this case, they appear to have nothing in common, and each of the elements is empty. So yes, I would agree that this is a true statement. This is a true statement. Because if A contains anything, if it had just one number in it, well then union would not be empty. If B contained just one number in it, then the union would have that one number in it. So this thing is actually true. Both of the sets has to be empty for the union of the two to be empty. In question 9, we have 1, 2, 3, 4, 5 is equivalent. This is the equivalent symbol, which means can I produce a one-to-one correspondence between the two? And we're asking, is 1, 2, 3, 4, 5 equivalent to D, E, F, G, H? Well, we have to make sure they have the same number of elements. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yes, I can make a one-to-one correspondence between each of the numbers and then the letters. So this is an equivalent set. It is in fact true. We can make a one-to-one correspondence. In question number 10, we're asking, is 512 an element of this set X such that X equals 2 to the n, where n is a natural number? So let's make a list of numbers. We have this is 2 to the 1, which is just 2. 2 squared, that's 4. 2 cubed, that's 8. 2 to the 4th, that's 16. Now the question is it possible to get something 2 to what power will give us 512? So I'm going to ask that question. 2 to what power gives us 512? So let's make some guesses. I'm going to use my calculator for this. And I guessed 9 here on my calculator, and 2 to the 9th is 512. So yes, it appears that 512 is an element of this set. So this one is true. Question number 11. Let's use the Venn diagrams to determine whether A intersect B union C is equivalent to A intersect C union B intersect C. Don't forget to state your conclusion. So let's label these as A, B, C for each of these Venn diagrams, and we'll fill in these with some numbers. So I'm going to put 1 here for this region. Let's say this is 2, 3, 4, 5, 6, 7, 8. Again, these numbers can be different than yours, but you'll get the same answer as long as you label each of the regions a different number. So let's try A intersect B. Union C. A intersect B. A intersect B would be anything that overlaps A and B. The intersection is the overlaps of A and B. So that's going to give me 3 and 6. I'm going to union that with set C. Set C is 5, 6, 7, 8. 5, 6, 7, 8 is in this circle, so that's set C. Now we're going to find the union between these two. Well, the union is just the list of all of the elements. So we have 3, 5, 6, 7, 8. And remember, I'm not going to repeat any of these for the union. So let's shade number 3, number 5, 6, 7, and 8. So this is the picture for A intersect B union C. For the second part of the question, we're looking at A intersect C union B intersect C. So let's look at A intersect C. A intersect C is going to be anything that is in both A and C, so that's just 5 and 6. You're going to union that with B intersect C, and that's what's in both B and C, that's 6 and 7. And so the union between these two is 5, 6, and 7. So we're going to shade 5, 6, 7. And so if you look at the pictures, they're different. They're clearly different. So let's state our conclusion. We have that A intersect B union C is not equal to A intersect C union B intersect C. So these are not equal. Example 12. In an interview of 50 math majors, 12 like calculus and geometry, 18 like calculus but not algebra, 4 like calculus, algebra, and geometry, 25 like calculus, 15 like geometry, 10 liked algebra but neither calculus nor geometry, 2 like geometry and algebra but not calculus. Of those surveyed, how many liked calculus and algebra? This is a difficult question unless we have a Venn diagram. So let's use our Venn diagram and fill in these numbers. So I always like to start out with the middle and find out who likes all 3 subjects. So let's just put calculus, geometry, and algebra here down at the bottom. So let's figure out who likes all 3. Right here we have 4 liked calculus, algebra, and geometry. So I'm going to put that number right in the middle. That will be 4. And then we can try to figure out the other regions. We know 12 liked calculus and geometry. 12 liked calculus and geometry. So we know that in this region the total should be 12, therefore this must be 8. 8 plus 4 gives me 12, so this has to be 8. I can use this one as well. I know 10 liked algebra but neither calculus nor geometry. So we can put 10 here because these are the only people that only like algebra, they don't like calculus or geometry. For this part, we know that 2 liked geometry and algebra, but not calculus. 2 liked geometry and algebra, but not calculus. So this has to be a 2 because we know that these individuals like geometry and algebra, but not calculus, so not this part of the circle. We know 15 people like geometry, 15 altogether. I have 8 plus 2 plus 4. That gives me a total of 14. So since geometry altogether must be 15, this has to be a 1. 18 liked calculus but not algebra. 18 liked calculus but not algebra. So I know that this part of the circle must be 18 total, so this must be 10. 18 people liked calculus but not algebra, so this is 8 plus 10, that gives us the 18. And at the very end, we know that 25 liked calculus, so 10 plus 8 plus 4. That gives me 22, and this circle has to add up to 25, so I know this has to be 3. So that's our Venn diagram. Double check to make sure your Venn diagram looks similar. So now we can answer the question, how many liked calculus and algebra? How many liked calculus and algebra? That's this region here. So we know there's 7. So don't forget to answer the question at the end. We know 7 liked calculus and algebra.